Victoria is from Scalebase, which does transparent scaling of MySQL databases. And she's going to talk about scaling MySQL with transparent database sharding.
Hi everyone. So normally I don't do this. Normally everyone is doing this. So I'm going to try to sort of be as elaborate as I can be. So just a few words. I'm Victoria. I'm from Scalebase. It's a small startup company. Actually, we launched the first version of our product in August. So we're still struggling. It's still not a perfect product, but it's a great idea behind it. And we are actually we are much better right now than we were half a year ago. Just to introduce myself, I'm a director of a R&D department. That's why I usually don't do this presentation. I usually deal with the programming more than I'm dealing with people. Nevertheless, we need to move on. So what does Scalebase do? We build load balancers, the database load balancer, which basically provides MySQL scaling, and we're going to talk about this later, which allows you to overcome the difficulties of huge databases and huge transaction rate that we need to work on currently. And basically, it provides you the ability to work on it elastically, meaning we can grow, we can make your database elastic if we need to. So as I said before, the first version, or version 1.2, was released in Q3 of 2011, and this version is pretty much in a good shape. We are working with existing customers, we have great results, and it's really a fun product to work on. So what do we need to, just to start with, it's not about the scale, but we just try to understand, and I'm not sure what the audience here knows or doesn't know. I'm sure every one of us is very intelligent, but just to explain why do we need to do this? Why do we need to provide scaling? Nowadays, databases, everything is database. You go to Facebook, you go to YouTube, you go everywhere, everything's on the internet. We need to store data. We need more and more database to be available to us. The database grows to a huge size. How do we support it? Especially for some companies who don't want to pay for big enterprise solutions such as Oracle and go with MySQL, and that's where MySQL is coming to the picture. So what do we need to actually support? So let's say we are hitting the limits. The database grows. We cannot load it into memory anymore. The transactions are getting slower and slower and slower. We need to buy disk, we need to buy hardware. How do we actually allow ourselves to compete with today's environment and actually make sure that everything is okay? So we have several options. Probably a lot of you are familiar with that. So some of the options we can, of course, do a simple thing that most of the people do is add more hardware. Add more disks. What basically it's called scale up. We add more hardware. We more or less okay for some time. Now it grows again because you get more customers, you get more transactions, you get more. You want to grow. Your company wants to grow, or whoever you're working for wants to grow. So what's happening is you're happy that you have more customer base. You're happy that you can handle more transactions. At the same time, you hit the limit after adding the hardware. So what's the next step for you? Okay, add more hardware. But again, it's not really realistic. At some point, you will hit the limit, and at some point, you cannot scale on that hardware. And so what are you left to do? There are several other options. You can scale out, what we call it. And there are several options. I'm not going to go through that in the details. You can read about this. All of them are available. But you can do partitioning, you can do read-write splitting, you can use a shared storage cluster, multi-master application, and of course you can do sharding. Just to explain, I don't want to go into any of those options into great details because the point of my presentation is sharding. But just to explain that none of these options is really, every one of these options eventually is hitting the limit. If you're going to talk about partitioning, eventually you're going to hit the limit of basically partitioning and splitting the data set. Instead of having one file from MySQL, you basically have multiple files. Again, you're going to hit the same limit. the limit of the hardware, the limit of the file size. You can split more, of course, but it's eventually it's not proven to be very elastic. Meaning you're going to spend a lot of resources, a lot of money, and you're still going to hit the limit. You can use read-write splitting. What does it mean? We're going to send reads. We're going to set up MySQL replication. We're going to set reads to all of them. We're going to set writes to only one of them. Again, one, which is going to take the writes, which is the master of all of them, is going to hit the limit. Again, with the hardware, as I talked about the hardware before. So now we're going to come to the concept of the sharding. So, and I'm going to basically, I copied and pasted here a definition from Wikipedia, so you can read it. But essentially, what is sharding? Sharding is splitting your database into several physical databases. It's actually physical machines, which are different. I mean, of course, it can be one machine if you want to, multiple SQLs, instances running on one machine, but it's not really practical. But what you can do, you can horizontally scale. If you need more data, you basically add additional machine. Each machine has its own CPU or multiple CPUs, memory, disk space. I mean, you can choose how much you want. So, what is this, the concept of sharding? So this is basically, I talked about this before. So you have one big database. Let's say you have, I don't know how many records we have 7 records. So we have 7 records, and what do we want to do? We want to split it. So this little cylinder basically indicates one big database. How do we split it? We pick and choose, and I'm going to talk about this, the criteria, how we do the splitting, the data. We choose some sort of criteria, how we want to move those records, and we're going to say, okay, database A, which is the first one on top, is going to have 2 records. The database B, which is in the middle, is going to have 3 records. The database at the end is going to have 2 records again. And essentially, from you can connect directly to each one of those databases. It's a single instance. Do they represent the whole data? No. But cumulatively, all of them, you can see it as one big database. There are not existing tools. I mean, there are tools, of course, it's us, but they're currently, even though we're talking about the concept of sharding, and it started a few years back, but the idea is it's not really. Yes, we can split the data, and I'm going to go with you through the exercise of how to do it. Let's say we have one big database, what are we going to do with it? How do we split it? And second thing is, how do you visualize it? Because existing management tools, if you're going to go to Workbench, if you're going to go to Toad, any one of them, you'll still be able to connect to each one of those small databases, a single instance of MySQL, run the queries, but if you want to do a cumulative query, like if you want to actually see what's in all of those shards, you'll have to, have either develop a piece of software if you want to, or buy our software, or maybe subcontract somebody else or some developers to actually create the software for you. So again, it's just a little bit of a slide. We talked about, I basically mentioned as to why to shard, and what I was trying to say, and I'm not sure, okay, I'm basically showing how if we're scaling out, eventually we're going to hit the limit. We're going to hit the limit of where we can scale up to. So the only option that is left to us is really to scale out, meaning to actually, if we want to add more hardware, it shouldn't be on the same machine, it shouldn't be on the same storage, it should be on separate machines which basically can work independently, but somehow we need a way to manage that and run queries and to manage transactions. So what are the benefits of sharding to begin with? I mean, what do we do? And we're talking about transaction. In our world, if we need to support a huge transaction rate, we need to make sure we are reliable. We need to make sure that all the transactions are eventually committed. We need to make sure that they're atomic. But we need to support it. We need to support it in an environment there are a big number of records. So what is happening? How do we perform in performance? First of all, if we're going to shard, the table size is being reduced. The index size is being reduced. Of course, we have more memory. less disk access because if you have one database and you can support, I don't know, 1,000 multiple threads or connections going to it. If you have 4 databases, you can support 4,000 connections to it. Isolation, of course, how do we do transaction isolation? I mean, it is a pain. So if you have, again, if you split your data, it becomes less of a pain because there is less of concurrent processes which are accessing one database. And it's just easy to make a database elastic.
So, but you will have to combine results from multiple shards together.
Absolutely, yeah. And what I want to do actually right now, I'm going to do a little exercise. I'm going to start with a small database, not small database, but just sample database. I'm going to show what in theory you need to do to actually shard it. And then we're going to go and move to the scale base because everything that is, I'm kind of describing, of course not in greater details, we are doing that for you. And then essentially, that's why we make it transparent. So, again, so if we need to shard, so how do we do that, first of all? So we have this one big database. You're using, most of you probably developers who worked with MySQL before, or any other database, right? So what do we start with? So developers usually, there's a constant battle between the developer and DBA. And in my experience working with different customers, it's usually DBA say one thing, developers say another thing, and usually it's not connected. So we have this application which is running. We're hitting certain limits. The database is becoming very slow. It cannot handle all the traffic, crashes, it stops. Transactions take long period of time. There are timeouts on the network. What do we do? So we need to start with a schema. So essentially, we do start with a schema. We need to take a look at the database in general. Look at the relationships between different tables in a schema, understand what can we do with this, which are the tables that we do need to shard, and which are the tables that maybe doesn't make sense. So and of course, based on that decision, once we analyze the schema, we split the data, and what else do we need to do? Update the code. Because now, existing tools, queries, developing applications, working with database, we can either use we can use a connection pool, but the connection pool knows only one connection. So somebody has to manage these multiple connections and direct different queries to different instances and make a decision which query should go where. So now I'm moving to this sample application that I was talking about. So it's called, I'm going to take an example, and maybe some of you are familiar with this. It's called Apache Date Trader. Application is basically sort of a load simulation. It's HTTP based, but it's a load simulation that provides a load on a certain database which allows you to test it. And the reason I chose it because it's very, very, it's small. It really has not so many tables. I'm not sure. I cannot even see on my laptop. Okay, so it's basically a web browser that simulates a trading application. So not as big as one of those trading applications allowing you to trade stocks, but a subset of these transactions that are usually happening during the day on the stock market. It simulates it in a way. There is a portfolio, you can manage your portfolio, you can work with various stocks, you go below the limit, but this is essentially what it is. It can be any other application that is any other database. So looking at it, so what do we have? We have 6 tables. So, and they're pretty much, I know the names are kind of confusing, but I took them as they were in the actual database. So, but, they're pretty much, the names are self-explanatory. So we have order, AGB, which basically enterprise Java Bean, but it's an order, a table which contains a list, which has a list of all the orders that were put through this application. Account contains account information of a single customer who is using that application. Quotes are basically the quotes for various markets. I'm not a trader, so I guess whoever is playing on the market, they can more relate to the quote. But it basically provides the relationship between how many stock markets, how it's all related, what's the change, what's the company name. Holding is something that you can hold. Once you decide to purchase, to buy a certain amount of shares, then basically that is stored in a holding AGB. Account profile is a very simple one. It basically maps an account of a user to an actual physical or something that is human can understand, like a name, address, password, user ID. It's pretty much all credit card information for that matter. And keygen is not even relevant. It's just for this, that's why in this case, it's actually 5 essential tables in this application. Keygen is just for random sequence generator. So, so if we look at it, basically we look at this database. Let's say somebody would contact me and say, hey, we want to shard this database. So what do we do? I would request a few pieces of information. Somebody who is developing this database, for them it may be easier because they know the queries, they know exactly. Some of the queries some of the customers are very aware of, their transactions, their queries are very, very well written. So it's very easy to understand, what to shard for and what do we need to shard. And some of the queries are written, all over the place. So they're not efficient, and it's very difficult to understand what is the actual relationship should be. So what I would need. So first of all, so we have a schema. So we'll need a list of table sizes. Why? For a simple reason, because we need to know on top of what queries are running towards those tables, we also need to see what are the biggest tables, because the biggest tables, for the most part, are going to be the ones that we want to shard. Why? Because, instead of having all these huge tables in one single database, we are going to split them across different shards, thus minimizing the size of it. Okay, what do we need else? The table relationships, all the foreign key constraints, whatever else we need to understand about how different, and it could be joins. I mean, it could be not direct foreign key, but it could be just a join that is going to provide the knowledge of the relationships between the different tables in the database. And of course, SQL query log. Why? Because again, as me, who I don't know anything, for me, this application is a black box. I need to know what is the application without looking at their code. Without understanding maybe the logic of the code, I need to understand what exactly they're trying to do, and queries and a lot of times actually, or transactions, they're allowing us to understand how it's all interrelated. So and of course the query log is going to provide us information about the joins. For customers who do not use foreign keys, for example. And it's just easier to work with, and of course this query log should combine or should contain all the functionality of the application. So normally, of course, the query log is closed on the system, so we ask the customers to open it, to have a run, like a sample run, and we get it and we close it and we don't let the system run. So we have all of this information. We have tables, we have table relationships, we have the query log. Now, it's pretty much enough for us to make a decision, if it's worth, first of all, it's enough for us to make a decision if it's worth sharding. Because some of the applications, to be honest, a lot of applications are, but some of them are just not simply the way they're written, the way the code was written, the way the queries were written. They need to be redesigned to be sharded properly. It's just because they're so inherently tied to the single database design that's very difficult to even start splitting them because the queries are so interrelated. A lot of unions, a lot of joins.
So SQL query log in MySQL terms is general
query, exactly. Yeah, you can open it. Open it, close it.
No, not slow query log.
No, that's not. Just we need a general one because we need to see all the subset of queries. And you would. Of course, let's say if you're a developer and you know exactly what you're doing in your application, you don't need that because essentially you know every single query that you're running in the system. But a lot of times, some applications that's been there for years. People who wrote the queries are no longer in the company. People who are working with them, they don't know what exactly the application is doing, or especially for us, if we're looking at the application and it's a black box, I have no idea what exactly it's doing. So I need to see that. Okay. Now we're moving to the table policies. And what are the table policies again? So now, imagine you have, in my example, I'm going to use 4 as a number, just a magic number. I want to split one database in 4 different ones, 4 different shards. It's just easier, I guess. It's not 1, it's not 3, but it's, I don't know why. We can pick any other number. So what do? So we need to make a decision based on all of this. What is the how do we look at the relationships? It's possible some of the lookup tables, there's no point to shard. They're too small. It doesn't cost us anything to shards. So these tables are called global, which means essentially you have the same schema on all the shards. But some of the tables exist on all of them, and they're exactly the same. Why? Because it's just easier, especially in case of the joins on a small lookup table or something of that sort. It just, there's no price for us or for anyone else. If we're trying to solve the issue of huge database and the table is small, there's no really a point not to keep it there, especially if it's going to solve us an issue of resolving joins. And I'm going to talk about all this conflict resolutions later on, but it's just for us to understand the global table is a table which exists on all the shards. A shard table is a table which is actually split. So this is a table which does exist on all the shards, but the data across different shards is completely different. The master table is basically a table which exists only on one shard. And usually it would be the table, for example, like in this case, we're trying to retrieve user information based on the account. Essentially the queries are running, okay, retrieve from this table based on the ID, so there is no really even point to keep it on all the shards, we just keep it on one. We can keep it on all and sort of distribute the data so that the read will be split between different shards. But again, it's sort of a design decision that there's no right and wrong here. So what do we start with? As I said before, again, the rules here for a developer or for DBA, it could be somebody would know more about the application and what they want to shard. Again, we had customers who were coming to us say, I want to shard these and these tables based on this and this key, and that's it. And then when we look at the log and we look at the information that they provide, we're absolutely agree with them. But in the most cases, of course, the biggest tables that are in the schema are the ones, the good candidates for sharding. Just because, we do want to alleviate that size. Again, what do we do next? We look at this SQL log. Are there joins within those tables? As I mentioned before, are there foreign keys? What can we do? Does it make sense to make the table smaller? Does it not make sense? If we're going to shard that table, what are we going to win from that? If for the most part, it again depends. What are the queries that we're running? Are we running inserts there on those tables, or it's mostly selects? Inserts is very expensive for any database, so definitely for the most part we're trying the tables which are with a huge number of inserts. We're trying to keep them in the sharded environment. Why? Because essentially we don't want to make it global. We don't want to do exactly the same operation in all of them. Basically, again, so as I think I'm repeating myself, but so there is tables which are not accessed frequently. Maybe they should be global if it's going to help us to shard tables which are more important. So with the traders, so what do we do with the day trader? So as I showed that table schema before, what is the biggest table in that schema where the order, the code, and the whole name? Of course, it makes sense. Why? Of course, the number of users grows, but essentially, and we are planning for the number of users to grow, but the number of users, magnitude-wise, the number of users is usually less than the number of orders of pools of holdings, because users are constantly trading stocks. So of course, these tables are, much bigger than the account on the system. So they are good candidates for sharding, and that's why we decided, okay, so if they're the good candidates for sharding, they're the biggest ones, so let's take a look at their queries and see if we actually can do it. And what would be the shard key? Now the shard key, again, the concept of a shard key, I'm not actually covering that much in detail later, but just to explain, that is for us to decide based on how do we, let's say we're going to split this data. We can randomly say, okay, put this part here, and this one here, and this one there. But how do we access it? How do we know which data is? And there are several ways to do it. I mean, you can split, again, it could be, if you're writing your own application, you can split based on, you can say, okay, if the user ID is a shard key, then we're going to split, based on the range. So any user between the range of 0 and 1, or 0 and 10 is going to go to shard 1, 10 and 20 is going to go to shard 2, 20 and 30 is going to go to shard 3, and so forth. Easy way, yes. So it's possible to do it this way. The other way, maybe a list. Maybe, if the sharding is something else, maybe you want to keep a list of all the members. Another option is to do the modular operation or a hash function. Whatever it is that is for a developer available to actually map exactly, okay, this is my shard key, and I want to run a query, and I want to know exactly which shard to run. So let's say if I want to retrieve user information from an account table, and I want to say, okay, the user has an ID of 0. I don't want to send this query to all the shards. I want to send it to shard number 1. Why? Because I know exactly, because in this shard key, the user is residing on shard number 1. So this basically, the shard key is sort of a way, think about this as like a key. Like, not a key, is if you get lost in the woods, this is the way, this is your breadcrumbs. This is how you get from point A to point B. Okay, so it's essential to understand that concept, because without it, sharding is, it cannot be useful. So what do we see here? Again, we'll look at the tables. We already agreed that these are the biggest tables in the schema. So how do we want to shard? So if we're going to look, there is something that right into the face. All three tables have one field in common, which actually I'm not shown on this slide, but it has one. All of them have one field in common, which is the account ID, and this is which is the key. In the code HB, it's not shown, and I think it's my mistake with the slides. But essentially, it's an account ID. Account ID is the same and common for all the tables. All the queries that this application is running are based on the account ID. So now we'll say, okay, we analyze the queries, however we analyze it, either by knowing the application or by us analyzing the logs and say, okay, running all of these queries, we do know that if we're going to split based on this shard key, we definitely going to be able to find this particular record, and we're definitely going to know where to send this particular statement. So now physically, in front of us, there's one huge database. So how do we actually do it? So it's actually a big question. And essentially, right now, let's say if we want to do it manually, and I'm describing right now a manual process. So we have one big database. What do? We need to clone it, first of all, to begin with. There are several ways. Of course, there are several other options, but the fastest way would be to clone it and use something like a MySQL dump to dump the data into all the shards. Maybe use the MySQL dump with the replication to make it the same. But essentially, at the end of this process, we'll need to end up with 4 databases which contain exactly the same amount of information. Why? Because that's our starting point. Now, we started one big one. We have now 4 big ones or 4 small ones. Again, the process can be different, and I'm not going to go into details of that, but essentially we need to replicate. So, and I'm describing the process. So now we have 4 equal shards. What do we need to do? Of course, we need to drop all the indexes. Because what we're going to do, we're going to, based on our criteria for the shard key, either it's a list or a range or a hash function or a modular operation, we'll need to drop the records. Let's say in our example, I think in our example, we chose to do it based on the modular. So what do we need to do? From the database number 1, we need to delete all the records, but the modular 4 is equal to 0, right? So, and so forth. So essentially, you end up, again, you do this manipulation on the shard tables because you need to minimize the tables. Of course, so that's what I'm talking about. Delete the irrelevant data from the shard. It's not irrelevant, but essentially, the data is going to be moved from one. It's going to be present only on one of the shards. Of course, as I said, this creates a lot of fragmentation, so we need to be careful as to how exactly we want to do it. And of course, at the end, we need to recreate all the indexes. So what do we have at the end? At the end, we're going to have 4 databases. The shard tables are going to exist. The shard tables are going to contain the data only relevant to that particular shard. The global tables are going to be the same on all of them. The master tables, if we can keep the masters, there's no point. But if we want to keep space, usually the master tables are very small, so there's no point to do, but we can drop all the records from master tables as well. So that's essential. So we do have the data split, but now what's the next step? The next step, of course, is to change the code. And that is a pain, because now we have all the shards, we have all the data, we have the algorithm, but all our application, all the existing, yes?
I'm sorry, I must have missed it. You had this concept of a master shard. How do you know where to go today? Is there one single point you branch off of?
I'm sorry, can you repeat it? Because
You mentioned a master shard. I'm curious, is that the way you know how to get to all the other shards? Or?
no, not necessarily. It's basically, again, it can be, we have this concept of a master. Master can be also global. Master can be also sharded, because let's say master is not relevant. Let's say if it's some group of data.
Is it a write master? What makes it a master? What makes it special?
The first shard.
It's just the first shard?
And as we're going to talk about the scale base later on, I'm going to explain more about the concept, but essentially it is a first shard. It's a shard that contains the data only relevant, I mean, it's a shard that has some tables which exist only on that particular shard. So it is a master, but it's not a master in terms of MySQL application. I think that's where the confusion is.
I guess what I'm confused at is when I come in as the application, how do I know where to go?
That's where we're going.
You go to the master one, yeah. Okay.
You don't have, I mean, the essential as an application, and this is what I'm trying to get to. So now the application, so we split the data. Now what do we do? And that's exactly the question. Because as a developer, now we need to understand, okay, where are we going? How do we know where to go? Even, for example, somebody told me, okay, here's your information, these are your databases, the data is split, and I said, I'm going to use a shard key. I'm going to use a module as a shard key. I think it's more understandable. Because essentially, you know, if records are evenly distributed, it's going to kind of evenly distribute data across the shard. So what do we do? And so what are the ways how we can connect to the database for a developer? For a developer, we can use a connection call. We can use the DBC driver to correctly access to the database, right? We can use the ORM. I mean, either JPE, I mean, the persistence of Java, or Hibernate, any other tool. So I'm going to call the Hibernate, the GPE, I'm going to call them the ORM. Why? Because they map. And essentially, the developer who's working with them, they have no idea what's going on behind this query. I mean, for the most part, there's a way, you know, to write direct queries, but for the most part, it's kind of a black box. Okay, I want to do this class, I want to save this record. It's pretty much transparent to a developer what exactly is going on the level of the database. So I'm going to start without the ORM. Without the ORM, it's kind of easy. Why? Because, you know, essentially what we do a connection from a connection pool, and we work with this connection. Now, what do we need to decide? We need to decide, okay, where to send this data, and that's where it becomes a pain, because essentially you need to analyze the query. You need to say, okay, this particular record, or you need to ask for the global tables. You need to say, okay, these queries or these statements should be executed in all the shards. What are the example of these queries? Probably, you know, the set commands. You know, you want to execute on all of them. If something in the change, you want to change something in a session, you want to change it for all the shards, right? So for a developer at this point, essentially they need to know, okay, I'm working with a user number, and usually we do know that. I'm working with a user ID 100. So user ID 100 should be located on shard number 1, because my sharding policy is to use the modulo operation. Or if you're using a list and you're saying all the users between 1 and 100 are located in shard number 1, I have to send this particular statement only to the shard. And it can be a pain, because you know, it may sound easy in a way, but it's essentially you need to override this particular. It needs to be handled on the application level. The application now needs to not just to say to a database, okay, you know, I want to connect to this particular database, and I want to execute a certain query. Now it needs to know to which database it wants to connect, which can be sometimes a pain, because you know, you don't actually, maybe some of the queries you don't know, or maybe you are not sure how the joins are working. Again, this is just a small, I mean, it's a very simplistic example, but essentially what it does, it provides, it's kind of in Java, but it's not kind of, it's in Java, but it provides a way, okay, get connection, get any connection. It's sort of, you know, get connection, and you provide a sharding key. So it's gonna, the pool is gonna return you a connection which is gonna be related to this particular shard. Let's say if your shard key, again, there is much more involved in that, but essentially it's as simple as that. We provide a sharding key, we need to know to which database we need to go. It's the developer's responsibility to do that. It's a lot of work that needs to be done, but essentially it's simple as that. Now,
So in your case, it will be account ID, the sharding key, right?
exactly. It's really, so in account ID, it's probably numbers, you know, 1 to 1 million or something, so you know where to go. So if you're working with account ID, and usually any transaction starts with, I mean, any application of that type starts, okay, user logs into the system, he has an account ID, so that's what you're working with. There's, of course, there are a lot of joins. For example, you want to, in that, and I'm going to talk about this later, but that's where we need to be careful. Unions, joins, anything that can go across multiple shards, that is a problem. And it can be very difficult to handle. So it's kind of a little bit more, but I think I've talked or covered most of it right now. But again, just to reiterate, we need to, for the shard tables, we connect the direct shard. For the global tables, we need to provide a connection to all the shards. So it should be some sort of wrapper that, you know, underneath has 4 connections in our case. And once we execute a query, it's going to send this particular statement to all 4 of them. You know, asynchronously, preferably. Because you don't want to send it to one shard, wait for the answer to another shard. So it should be very transparent to the application. So it's almost like it's executed on one. Of course, and again, I'm going to talk about this later, we'll need to make sure that all the transactions are atomic. Because if you executed an insert and it has to go to a global table in one shard, you want to make sure that this record is either A, inserted in all shards, or it's not committed and rolled back in case if there's a problem with one of the shards. And that's one of the biggest issues, which is, you know, we're going to talk about this in the two-phase commits. So, any questions so far? Should I go slower, faster?
No, I think you've done a good job of explaining about how much of a pain in the neck it
That's
is
the point.
to shard by, you know.
So-
Does anyone here do sharding in their application and has written all this kind of stuff and has dealt with all these problems? Yeah, some people have. Anyone want to do it after hearing you do? There's a couple of statists in the room.
It's actually fun. At the end, it's actually fun.
It's definitely challenging.
At the beginning.
Yes, that's true.
It's the resharding that's hard once you do that.
Oh, that's a kicker. And in the end, so
We won't even talk about that. Let's not even go there.
I actually put it on one of my slides, and then just realized, no, it's just going to be way too much. But yeah.
It's very difficult because a lot of people will hard code like a function like, oh, if your user ID ends in 0 through 5, go to this one, and it ends in, you know, 6, or 0 through 4, and it ends in 6 through 9, go to this one. What happens if you want to test out a new feature? Like the best thing to do would be to have a lookup table for every user, and then just populate it by saying, okay, if your user ID ends in this, and that way you can take out like 2 users, like yourself and your boss, and put it on a new feature or something like that. But it's hard to think ahead like that.
Right, most of the time.
Unless you've done this kind of craziness before.
Absolutely. In the legacy applications, we see a lot of like this hardwired sort of method of saying, choosing which shard to work. Again, as I covered, group by, order by can be very complex because it's basically, aggregations can be very complex. Let's say if you want to select star from all the shards, you need to aggregate, right? So because I mean, select star is not something that people normally do, but let's say if you do want to, or if you want to say, okay, you know, get from all the shards users who, I don't know, if you're on a dating site, select all the users who are Russian, for example, since I associate with that. Then you basically, you go and you take the data from all the shards. Now you need to aggregate, you need to return a result back, right? So that is also a pain. Enough said of that, and I'm not going to talk about ORM for one simple reason that on the ORM level, currently there is actually no way to do it. because it just doesn't support okay. So now, I'm going to move to scale-based. So scale-based, what is essentially do we do? We talked about analyzing first, analyzing the data. So, and it's kind of a little circle here, but essentially a scale-based analyzer, it's a tool that we've developed that allows you to do all of this analysis basically automatically. What we do request the SQL log file, we do request the table sizes, of course. We do request the schema, but what the analysis does is put the weights on certain relationship and certain constraints in the schema, and it essentially comes up and it counts, it can parse a huge SQL log file instead of parse it, identify unique queries, understand how it's working. What is the number of unique queries? How many queries actually that are being executed in a, we're talking about, what is the magnitude? We're talking about 1 transaction per day or 20 transactions per day or maybe 1 million transactions per day. So what it does, we plug in all these numbers and it comes up with a certain configuration, which is called our scale-based configuration. Because all our configuration is stored essentially in a database, which is redundant, which is, but essentially we do need to know, we do need to know where the shard is going. We provide the tools for you to configure that, but essentially it has to be stored somewhere. It's not just sort of decided. So the analyzer comes up with a possible configuration for this customer. For the most part, we are right now, but there's probably 90% of the cases, and 10% are still kind of need a human reading. So, but based on what we can see, we're improving the analyzer tool constantly, and essentially the idea is it's going to be able to do most of the analysis on its own. Data federator, it's essentially what we call it's in our database. It's what we call a scale-based configuration database, allows you to understand where the data should go. Shard dispatcher, this is actually our engine. It decides where to go based on the configuration, based on the query, which shard to send the data to, all, one, master, and and it makes the decision on the fly based on the statement which was provided, based on the configuration which was given. Results aggregated, that was talking about. In some cases, we do need to aggregate. We do need to get the results from all the shards. In this case, we need to aggregate the data to send it back to the application, so that the application can see it actually as a single entity. Shard reviver is something else, which is basically allows you to. It's still in process, but it basically it allows you to, once a shard is failing, it allows you sort of to do the automatic sort of restoration from the slave. And this is the big picture. So what it is, so you have your application server, and you have maybe 2 application servers. You have your terminal, you have maybe your management application, which is basically connecting to machine where the scale-based load balancer is running. So, and this scale-based load balancer, what it does, you have database A, database B, database C, database D, and it connects all of them, and it makes a decision where it should go, where it should go, and what to do with it. So now, of course, what if, the natural question here in this architecture, which I would ask, okay, so now we kind of made sure that databases is not the bottleneck, we split them, they're small. So we're going to do, so what about us? All this data right now is hitting scale-based. So what we're going to do with this? How are we going to handle that? How are we going to, so now are we in a position here? Are we creating another bottleneck where essentially, we cannot handle this traffic, even though database is sitting idle and they're pretty fine there, right? So, and there's an answer to that too. So you can have this configuration. And this configuration, if you need another machine on the scale base, you have another machine. And these 2 machines, they're gonna be able to talk to each other. They are talking to each each other if it needs to be, but essentially they're communicating to two shards. So what you can do, you can have your load balancer, which is either connecting to one machine or another, sends all the queries. Again, in some cases you do need to be careful, for example, in case of transactions, but essentially this is, for the most part, it's being taken care of because the transactions are usually on the connection level, and the connection is usually kept for the most part. I've seen different, but it's kept on the level of the balancer.
Is that dynamic load balance?
It can be, you can use your application, you can create a pool of connection. You can say, okay, I want to create a pool to this balancer, I want to create a pool to this balancer. Or you can basically, maybe in Amazon, you can create a load balancer there. If you're working with Amazon, and a lot of customers lately are working with Amazon a lot just because, they provide their RDS, they provide MySQL. It's pretty much, it's kind of expensive, but.
So if I have a dynamic load balance, two in your case there, and I commit to one load balancer, do I wait until it commits to the other load balancer to be sure?
No.
Then
You
what
work
happens if I go back in and ask for how to, and then get the other load balancer?
Again, it should be done on the level of the TCP connection, meaning probably you're facing one IP, right? Your TCP load balancer has an IP which you are actually connecting, and it's doing all the distribution on it. So for you, it should be really transparent for the most part. Because what's happening on what the load balancer usually does, it sends to either one IP or another IP, right? Or 3 IPs for that matter, 4. You can, I've worked with a
Right,
system.
so it's transparent. So my question is, when you go to one and it commits it, and you're all set with that one, and then you go back in again and it transparently sets it to the other one, and you haven't committed it to that, do you have a hole there?
When you don't commit it to the
You
load
don't commit it.
balancer, you commit it to the database. So
Mhm.
let's say you commit it to something on database C, you go to the other load balancer,
It knows it's on
and you
database C.
pick it up, you're gonna pick it up from
Absolutely.
database C.
How does the other load balancer know it's there? Because it's pre-sharded?
It doesn't know it's there, it's just where, it knows where to go to find that
Sharding is
user
kind of
For you,
information.
it's transaction after transaction. So you send one query. Let's say you're inserting a record and you're looking up for this record, right? So you committed, so the record is there. It doesn't matter whom you're going to go to. If the record is there, it's going to be returned. For us, it should be transparent.
So none of the data records itself are on the load balancer?
No. No.
The TCP load balancer just says, I can handle a certain amount of throughput. The scale base has to have the logic built in, if that makes it clear.
Thank you.
And it could, first query send to first load balancer and second one to another one, third one, just switching between, that's it. Not a huge logic, there is nothing to reside over there.
Yeah, for us, there is no data which is stored. No database data. So all your commits are commits to the actual database. We do need to handle them, but essentially you're working with the database. Okay?
Thank you.
Got somebody over there.
Yes.
Your load balancers, are they metric-based or round-robin-based?
We don't provide load balancers usually a customer. We provide a scale base, but you can
Okay.
do whatever. We actually, our load balancer, you're talking about?
Well, I didn't know if your load balancer would provide a metric back to the TCP load balancer, so that way, if yours is hitting a particularly heavy insert that bogs it down a little, it would sit there and say, okay, send to the other one, we're
No.
too busy.
No, this is not done. Usually the load balancer essentially is transparent. We have a machine running, we have an application running on that machine. We don't feed anything to the load balancer. We have our, essentially once the data comes, how do we route the traffic, right? So the request comes to the TCP load balancer, so it knows where to route. It basically picks one of them. So it's gonna, for that particular connection, it's gonna route all the requests to this particular balancer. We don't need to feed anything. You're absolutely right. You can have multiple connections. So if one connection is busy with the insert, you're saying, or that select, if you're running select star, it can be busy, of course. But
The old style is the round-robin where it just says this one, this one, this one.
as far as I know,
There's holes in that.
yes. To be honest with you, I worked with load balancers before. So yeah, you're absolutely right. It's round robin. I think some of the advanced, right? Again, we are not responsible for them. We are not working with them,
Yeah.
so I cannot really, vouch. Maybe some people here actually know more. But as far as I know, as I've worked with them before, it is round robin. So the only thing that the load balancer actually does know whether or not the IP to which is supposed to be routed is alive or not. Whether or not it's stored.
might consider in the future getting like a metric agent or something to feed into the load balancer? Would be
Maybe
a
it's a
lot
good
more
idea.
stable.
Yeah. Well, we have a long way to go, so,
Yeah, just
you know, open for ideas and
throwing
suggestions.
ideas out there.
Okay, so, but in general, this picture is clear, right? So you can add multiple scale-based. We're talking, I've added to this picture the standby machine, so you can have, you know, your slave configured if you need to for the backup purposes. Again, the replication for now, I mean, it's done on the MySQL level, so we don't actually, currently, we don't actually control that. There are some features which we're working on right now, but as of now, in this picture, you know, database A and standby A, it's actually regular MySQL replication. Okay. So now we zoom in a little bit to the application that, you know, and that is basically the little balancer that we have in the picture before. Now it's a big picture of that balancer with all the subcomponents there. I don't want to go that much deeper into the details. So what do we provide, essentially, which things I do want to talk about. So, and it's right on top, management and monitoring. What do we provide? We provide a management console. So you essentially can manipulate from, again, once you connect to us for scale-based, this database is, all these 4 databases for you is essentially transparent. For you, it's just one database that is connected to that. So you run the queries, you think it's one database. You don't need to change anything on your application. You just basically run the queries. And as you run before, if you want to work with ORM for that matter, you work with ORM. Because ORM is also, you just get the connection, get the IP, and everything is going to work. For the JDBC, the same thing. You connect from the JDBC, from your perspective, from the application. That is the most essential point. We look like a single database. If you run select star, again, for whatever reason you're going to run it, you're going to get records for all the 4 databases. Okay? There are tools that we can use if we need to for monitoring purposes to actually connect just to one, even through us. We're going to give a hint. Some, you know, system administrators maybe want to, okay, I want to connect into this database. We also provide a tool to see data in all the 4 charts. For example, you want to see, you are going to tell us, okay, I want to see how many records I have in this table on all the 4, or 5, or 10 for that matter charts at the same time. So you run a query, you select star, you give us a hint. I want to get this data, split it across the charts, right? And we're going to return back to you a result set, which is actually going to contain the count of the records in a specific table, which is relevant for each single chart. So that is an tool. So, and why I'm sort of trying to reiterate that point is because it's really a pain. It's very difficult, as I explained before, working with the code, to do that. So when you don't need to change anything on your application and it's transparent, you just plug us in and you work, that is actually powerful because you don't have to deal with any of the pains of trying to go to this connection or that connection, trying to work with the aggregation or trying to work with the unions. Everything is done for you in the background. And of course, we provide a visual tool to sort of, it's a web-based, HTTP-based, basically, it's a visual tool which allows you to visualize your databases. So you can see our configuration in the next phase. Right now, it's just the basic thing that we're displaying there, but in the later stages, there is a big development which is going on to actually support sort of view of multiple things, the CPU, the memory, so you can log into the management console and you see all the shards. Again, if it's one, and this is another pain that customers who are going to Sharding actually experiencing, because before they had to deal with just one database. Right now it's 4 in our application. But what if you want to add more shards? Let's say if you want to, you need more. So you can do 10, you can do 20. We ran our benchmark with 32. So let's say if you need to connect to each one of them and run a certain query or configure something, it's painful. I mean, 32 shards, it's really painful. So it's essential to have, in a small number of databases, yeah, you can kind of deal with 4 databases, or 8 maybe for that matter, but 32, it's not something that is manageable for a human. I mean, it is manageable, but a human being who would want to actually do that all day. So we have So if you're going to go down, and this is the management and monitoring, this is something that I wanted to cover in details because again it provides sort of this unified view of all the shards in one big picture. Now what do we have? We have optimized parser. It's more on the code level. Why? We don't want to do all the parsing. The database is doing the parsing for us. So we don't want to actually spend this extra time and adding our overhead to do the normal parsing as in MySQL does. So what do? We do just sort of a subset exactly as much as we need to know to understand where the query should go. And it's really fast. There is, and for us, it's not a full parsing as MySQL. We do detect certain issues on our parsing, and we might return a different result. But there's mostly parsing issues. Let's say if you made a mistake in your column name or is general SQL syntax errors. There's, you're going to get an error from MySQL. MySQL is going to do the actual parsing today. Again, I mentioned it before, distribution decider engine. This is the one which actually, based on the parsing results, is going to make a decision which shard do we need to go to. Okay, so, and that is once the distribution decider is an essential part. Why? Because it does have the control. It's sort of at the central location which does have the control of where we need to go, where this data needs to be taken from. Policy management. This is basically our configuration database. This is how we know, again, we do need to know which shard to go to. That's all stored in the configuration because we actually do configure. We say, okay, this is my database. It is sharded. This is a table that they are sharded. These are tables that are global, and this is a shard key for the shard table. So that's all stored in this configuration database. So we call it the policy. This is a policy for the customer. Distributed transaction management. This is kind of not relevant. I don't want to get into that. Again, the most important one is the result aggregation. So basically, if we go SQL command, so we in between, so we have a database, we have a client connecting to us, and he thinks it's a database because we speak MySQL protocol, right? So we connect to, they connect to us, they send us an SQL command, we do some certain decisions, send it to different databases, we return the result back, we aggregate the result, and they return it back as a unified query. Okay, so that's important. So all of these 4 databases for client are really transparent, or 5 or 6. So again, the decider agent, I don't want to get too much into the details of that, I think at this point, because I covered that. We just basically store, what are the shard tables? Again, here we call shard and split interchangeably here. Global table, master table, what is the shard key for each table is important for us.
Questions?
Oh, sorry, I should look at the audience more.
So what happens if one of your database servers is underwater?
Mhm.
You have one shard that's responding very slowly. What does the application see for results? Do you see partial results, no results? How do you handle that?
You see, what we did, we created our own driver. So basically, we connect to the database. We are not using JDBC, we're using something else, which is homemade. And essentially, we do see if there is a problem with the shard. If one of the shards down, you're going to be working in the partial mode. Why? Let's say if you're going to work with a part.
I'm talking about slow. It just happens to be overloaded for some reason. Let's say this one takes 20 seconds to respond. That one is 3 seconds.
Okay, so this is a feature for the, I think for the next phase.
Okay.
It is, because it's actually a question which was asked by one of the customers, because before, right now, as we do right now, we do the regular ping. So the com ping command, which is sent on the MySQL level to the database, if the database responds, we consider it up. If it doesn't respond, but you're absolutely right. There are some cases where just database is closed up. So we're going to.
Right, just didn't guess right about how it should be sharded, and there's a lot of activity.
We guess right. Trust me.
That never happens.
So the current release,
So I guess that's the question really was with the current release. Let's say one database is taking 20 seconds to respond. You see 20-second response time for the query, right?
for any query that has to use that
The
shard.
shard touches that shard.
Right.
Well, whatever touches that shard in particular. You're not going to see, let's say, if there's a query which is completely going to different, you're not going to see any.
Sure.
It's going to work like this, yeah.
Right, but without sharding, you would, that a query would be, that server would be affected, the server would be affected, and it would be every query. So, It's still under
We're
improvement.
wandering into the rat's nest. There are a lot of possible solutions, right?
Well, yes, there are a lot of possible, you're right, there are a lot of possible solutions, but.
Okay, so, any more questions?
I have a question about scaling out. Can you scale out dynamically?
Oh,
Can you plug in a computer?
And this is something that you want to talk
The question is, can you scale out dynamically?
Yes, we can.
Yeah, and the answer is yes, just in case anyone didn't hear that, because that's a very important question and a very important answer.
It's very, it's, as I said, it's a very, it's a difficult process if you think about it, because essentially what it requires for you to reach, depends what exactly your application is, but it will require for you to reshard. So yes, we can. It's a feature that we do provide. Again, I'm not covering it here. If you want, like, we can maybe cover it on the Q&A session.
So the only question I've got is, does it rebalance?
It does.
Reshards?
It does reshard. Oh, 1 second. Okay. Here.
Can't see any of it.
That's what I'm saying. But essentially, it's kind of a decision-making tree as to how we decide where to go. We're going to one shard, all shard. Is it insert? Is it because it's essential for us with any tables? Let's say if it's a global table, the table that exists in all the shards, right? And it's a select query. It's enough for us to run it on any of the shards because all the shards are the same. If it's an insert query, on the other hand, we need to make a decision and run this insert on all the 4 shards, or whatever number of shards there is. So it's kind of a decision tree, simplified decision tree. It's how we're making a decision where to send the data, because it largely depends on what kind of query, what kind of statement is sent to us, and what kind of table we're dealing with. So again, I can probably magnify it, but I'm not sure if we want to go through that, but it can be quite complex. We can, I mean, does anyone feel like we want to get into that?
Well, I had a question about, since you're pulling the data across, does scale-based become a spooling as well as compute node for all that data?
It
Is
depends.
it spooled into memory or is it spooled to disk?
Memory. We don't work with this. But again, as I said, for example, you do need to, let's say if you're going to run select star, right? So for example, and it's gigabytes of data, probably eventually, you were going to run out of memory on the GVM, so that can happen. But we do spool because we need to read this result. We do. But again, in some of the cases, if we're working directly with shards, it's instantaneous. It's basically a network. It's read from the network and write to the network. But if we don't need to make, once we made a decision it's a shard, it flies in and out. Okay, so we do read it into the buffer and we send this buffer back. It's quite fast. Again, I asked the question again. Does anyone want to go? Yes.
Well, so related to that, if you have an order by and it hits 2 different shards, how do you deal with that? Like, say you could probably order each one, but then do you merge them after that? Okay. So.
If you lost one of your scale bases in the middle and it only is doing part of the compute node because you configured it to handle the load balance, I'm assuming you're distributing the load, what happens to let the person know that insert or that select failed?
Well, first of all, the query will fail, if that's what you're asking. Again, we do load the data, but it's essentially the same as your database does. We're gonna say, you're gonna get from the network from your client. There's no connection to us. If you're connected to a database, the second one is going to be available to you. If there is a second one, the second node is going to be available.
I'm not talking about, the database could go away, but what if one of the middle scale-based load balancers?
If you go back to that picture,
That'd be great.
This or this?
no, go back. Back to the one that had the architecture that showed the TCP load balancer or the scale base.
Scale-based.
This one?
No, keep going back. We can't see it on the screen. It's still on the same slide.
Decision tree.
You might be going back.
Because mine's going to. Sorry.
That's what I figured when you're like, how about now? How about that? It's like,
So I think I need somebody's who helped me before. Oh, no, it's working, okay.
There we go. That one. There we go. So what if one of the green scale-based database load balancers, is that the question, goes out?
Yep.
It
I would
both-
assume the other.
What happens if your data center blows up?
We're going-
No, not going back down
Yeah.
that trolling rabbit hole.
So both, if one of them going down, which is still, I mean, let's say if you're in the middle of a transaction, this transaction is not going to be committed. You know, it's, when you're coming to this data machine dies. What do you expect it to happen?
What do you think's going to happen?
Well, I think in this scenario, the TCP load balancer wouldn't send any more traffic to it. But is that what you're asking?
Yeah, machine, it's not responding anymore. So basically, if you're in the middle of the data, let's say 100 connections to this scale-based machine, they're all running queries.
Would there be some sort of, you need to replay the insert or you need to replay the transaction? Would that information get logged somewhere that specific
The
thing was
connection
lost?
dies on the database level, the database will roll back anything at this point, because our connection to them dies. So it will roll back.
So in other words, the scale-based server isn't holding any state about the transaction, it's not holding any content in the transaction.
No, we do hold the state if we are in transaction or not, but it's mostly for failures, not as drastic as server dying. If the
Right.
server
Also,
die-
you're not the only thing that holds it.
Exactly.
I think the distinction that there's no information that if you lose the scale base, you don't lose anything.
No.
Because the transaction will roll back or whatever. It's not, there's no special information in there.
Right, so from the client side, the client connects. Right now, normally you connect to your database. What's going to happen, let's say if you lose a connection, what do you expect from the client perspective? You're a developer of the application. You don't expect anything to be committed, right? If you're working in the not auto-commit mode. So what's going to happen? Nothing. None of them was for the application it needs to recover, and most of the applications have their recovery mechanism. So let's say if we wanted to commit, even right now with the databases, right? So if we want to commit, if you want to insert a certain, I don't know, payment, right? So, and database dies suddenly, or before you hit the commit. So it's essentially the same on our level. You would die, we would not commit. Application will have to deal with this, because that's what's happening right now. So from your perspective, it is transparent, whether or not you're connected to the database. We don't hold that data. We are not going to say, restart and say, okay, let's commit all these transactions that the user did. No, we don't do it. We do exactly as the current data database does.
Actually, let me jump into that a little more, because I get what you're saying, and I think I can confuse this a little more.
Thanks.
Does anyone not confused? Raise your hand, because we'll,
Because what if the client is looking to do an insert that the shard-based load balancer breaks up between database A, B, and C, but then after the scale-based sends the commands out, say database B fails, do you now have a situation where the inserts were done on A and C, but B is left?
Good question. We used to have this situation before. We don't have it right now.
You talk about two-phase commits, two-phase commits.
Yeah. Anyone else?
So if I understand this correctly, each database is a single MySQL server, right?
Yes.
And there is no database, there is no server on the load balancer.
Like database server?
Yep. What I was wondering about is, as a follow-up question to the order by, how do you sort results coming from different nodes?
It depends. I mean, it's a good question. It's more internal, but some of the queries we do change. We add additional fields. We have our logic behind that. But we do, I mean, some of them we let the database sort by changing your query because we know we're working in the sharded environment and you know. Some of them we basically do sort once we get to the top of that.
it depends on what you're sorting by. Like, let's say you're sorting by the user ID. That's, or you're already getting it in order from the shards, assume you sharded on user ID.
Mhm.
Right, but if you're ordering by like date or something, that's different,
If you're resorting, you're running a MySQL instance in the server, or you just have to run it in
Memory.
It's code.
Again, some of them we do, it's again, the mechanism, I don't want to go into the, on the programming level.
I have a question under the question was
Yeah.
sort of, does that create a capacity limit for the size of the result sets and things like that?
If we're talking about million of records, yes. Okay, but again, in the million of records, again, for the most part, we're trying to let the database do all the work as much as we can. There is algorithms that we do implement, but we're trying to make sure that the database knows how to do it, and trying to do as less work as possible on our level.
Sure. I guess I'm just trying to imagine, for instance, if you do a top something kind of a query, do you end up in a situation where you inadvertently have a lot of data showing up at this server to get resorted across shards to then figure out what the top records are?
It depends. No, this is actually talking about the limit.
Yeah.
So
The
limit is
reality is your customers haven't, I mean, if people haven't run into that as a problem, that's great. It just
no. I mean, you're absolutely right. It depends, but again, it depends what your query is. If you're going to do select star and limit 100, you're going to get data, I mean, sort of randomly. Pretty much you're going to get it from one shard. If you use a shard key, let's say if you're going to say, okay, like select from there, where, and there you do the limit. So pretty much, if it's a one shard operation, we don't care. We don't need to sort anything. We're going to, database is going to return the result with the limit. So it's actually, for the most part, it's problematic in the queries which are going to all the shards.
Right.
And, that's, but it depends on what.
But it sounds like that's the kind of thing you could just teach the developers to
Right.
say, okay, if you're going to do a query that touches all the shards, please put some sort of restriction on it so you don't.
Oh, yes, absolutely. Yeah, we do that.
Yeah.
Yes. Okay.
One more question. Is hash function the only type of sharding key that you use, or is it
Which one?
hash?
No.
Do you have a variety of them depending on?
Currently, we have 3, and there is a feature which is being developed, sort of like 2-level sharding. But essentially, currently we support list, range, and hash. So that's current. There is a few requests that some people wanted to do a more advanced sharding algorithm in terms of selecting, so you can use like a hash function, for example, or this is decide what the logic is, right? But currently, these are the 3 ones that the 3 main, actually, the only ones that we're supporting.
Does this work with partition tables?
Yes.
The question was, does this work with partition tables? And the answer is yes.
Are you going to provide any other DBMS other than MySQL?
We were supposed to do it, but there was no need for that up until now. There is a feature in the progress. I mean, that's in progress. It's actually on the shelf right now. Yes.
Little R&D problem?
It's a sales problem, I guess. But it's, I mean, there is, originally the idea was support, multiple different databases. We focused on MySQL because there was a market for that, because essentially you were hitting, this is essentially a database where you do, you don't want to spend, if you're using MySQL, for the most part, you don't want to, I mean, you do not want to spend that much money, right? I mean, you don't want to invest thousands of dollars.
You don't want to spend Oracle money.
Exactly. So this is
If
where.
you have Oracle money, you can have
But at the
Oracle.
same time, you want to overcome the, the problems of MySQL. You do want to be able to scale. You do want to have a good database to work with. So that's why the market for now, and again, I'm not going to answer for my sales guys because they're going to kill me later. But for now, this is what it is. Okay, so.
Quick question. While we're on the topic of not Oracle money, and this is still on the screen, what is what would be your opinion of a scenario having only 2 databases to do the sharding and having the scale-based load balancer running on one of them?
Are you running the scale base on the same
Configuration.
machine as the database one because you don't have a lot of physical hardware?
Correct.
You can do
As a tribute to not Oracle money.
Right, well,
I
I guess on the
I
flip
mean-
side, if the database is busy, your load balancer would become busy
Sure.
as well.
Sure.
it's just being aware of the risks, right? If you've had,
Right, I'm
if
just-
that machine dies, then
Then the whole-
2 of your
everything's
services have
down.
died.
Sure, sure. I'm just trying to understand from the perspective of.
You can.
uh,
I mean, can we do that? Yes, absolutely. We support that. Now, in
Okay.
our development, I'm running 4 servers on one machine for my SQLs, and my scale-based server is running on the same machine, so we can do that. I mean, physically it's supported, but again, you have to be aware that there's a CPU and you're working on the same. Maybe you can, I mean, it's up to you, but it's possible.
Sure, I just wanted to have an understanding of how we talked about that. It is all memory, when it's doing aggregate functions and stuff. I was just wondering, oh no, we made it that by default, it always allocates, 3/4 of the available RAM on the machine, so you could possibly do that
You
configuration.
just buy a bigger machine. I'm just saying, it seems like you'd create a single point of failure though. If that machine crashes, you can't use the other node either because the load balancer's gone.
Sure.
So I have a question for Ricardo. How much RAM do you normally use?
It depends. We,
Can you hear the question?
Sorry, what's the question?
How much RAM do you normally use is the question.
it depends on what kind of queries you're running, depends on how many connections, what kind of load you're running. I mean, if you're talking about we have customers, they're running huge, low data in file, and very frequently it's the first. So for they're running with 5G. I mean, but for my development machine, not nearly as much. It depends. It's really,
You say 5 gigs?
yeah.
That's not a lot.
What I'm saying, that's but where you can configure more if you want to. And again,
I'm just curious on what the range is, because he's talking about, can you run on this machine because he might be concerned he needs more RAM. But 8 gigs is,
Right, but
16 gigs.
I got 60 gigs in my home machine for $100.
Of RAM?
Cheap.
Yeah.
Yeah.
16,
16.
not 60.
No, not 60.
Oh, okay. Wow, really?
I got a really cool home machine.
Wow.
Costs more than my car.
Yes, but it's up to, again, we can figure that, it depends on your load. If we were running some tests before and, let's say we were running, I think, 1,000 connections or even more than, then you need bigger machines. If you're having queries, then of course you need bigger machines. It really depends. I cannot really tell you what is the must. Okay, so, I mean, if your transactions are pretty isolated, if you're just working with easy queries, then you don't need that much of a memory at all. Okay?
How do you handle auto-generated columns? Sometimes you use this auto-generated or primary keys. Is it within the scope of
Okay,
what
so
you do?
it's a very good question, actually.
Can you repeat?
How do we handle auto increment? Yeah, so we and this is a problem which is one of the things that probably, people need to be aware of is currently, we do that on we let database to deal with, which means if you're going to insert sort of the same, it is potential that there could be duplicates across, let's say if you have 4 shards. So we haven't had situations like that, but to answer your question, the database deals with that. So, I mean, we don't deal with this as it is right now. Okay?
So two machines, they could have the same number?
They could if your queries are written that way, yeah.
So you don't have offsets?
We do have offsets. That's what I'm saying, but again, it doesn't, nothing prohibits if if queries are written, okay, insert record number 1. Okay, so it depends how exactly queries are written. We do it via the offsets. When we create a session with a connection, we do set the offsets in such a way that they should not be duplicated. Okay, because for us it's important. We need to know what the offsets are and what the increments are. That's how we keep the data. For example, we're talking about the modular, right? So we need to make sure that the offsets are, properly aligned. But essentially, there are situations depending on how query written that because we don't check. Let's say if you're trying to do the insert, we are not going to check anything for you. As I say, if the database allows, and it can happen.
Does that mean you can't partition on an auto increment?
No.
Sorry.
No as in yes?
No.
I mean, it can get complicated, let's put it this way. It has to be, basically, what we need to see is exactly what are you working with. Okay, what kind of, I mean, you can partition, of course. Some of the times, for example, you do ask to do the auto increment for you. So that can happen. So it's again, case basis.
Right. I would think it wouldn't be a very useful product if you just couldn't do it because most people shard on something that's, like a user ID or something.
No, absolutely you can. But again, it's just that you have to be careful. These are the critical areas, and this is what allows us. It's also a question: why we do an analysis? Why do we have an analysis tool? It's because that helps us understand if there are any potential pitfalls. Can you run into them? Okay, because you can do a lot of things. You can connect directly to one of the shards and do a bunch of inserts, and we would not know about it, right? Because if it's not for scale, we don't know about it. But, you know, this is part of the consideration, this is part of the design that, you know, that we're going through as we're doing the analysis.
I don't know, because I've charted quite a bit, but in the situation there, if you add in more databases or whatnot, how are you reconstituting data? Like, if from what I understand, it's the resharding that catches you later. Like when you've got more data or you've lost one of the shard masters, and you've got to essentially promote something and put something into play. You were saying that the load balancer knew how to replay the data. Is that what I understood? So that if database E came into play and database A went away, database A data would get replayed into database E?
Not that way, because they're two different. So they're two different. You're talking about, I think we're kind of mixing if one of the databases failed, then we need to actually redistribute the data by adding more shards, right? So that, which one are you talking about?
I'm inferring it in both. Essentially, if you know that database A has 1 through 10, B is 11 through 20, C is 21 through 30, so on and so forth. If you lost 1 through 10, then, and you didn't have, you know, anything at the top, how would you recreate that?
We cannot, that we cannot recreate. If that's the only copy that we have and you lost the data completely, then we don't, you know, of course we cannot do
Yes,
that.
it's not RAID.
Okay.
Unless
So-
you have a backup and you want to, but again,
That's
you,
what like the standby would be.
right, the standby is exactly for that purpose.
Okay.
But if we detect if the database goes down. Let's say most of the configuration is that you do have a backup. The backup is a replica. So once we detect that the fail on the primary, we're going to use the secondary.
Okay.
Okay, so that's if that's the answer. But let's say if you don't have the backup and you lose the primary completely, there's no data, everything is gone. I don't know, it's flooded. Of course, we cannot do that.
No worries. Just wanted to understand when you had said, you know, that it could replay what it was involved.
Is the recovery mode for the database load balancer basically keep a virtual machine or a machine configured as a snapshot of the others with a different configuration file and just boot it up? I mean, there's nothing really there but configuration information?
Yeah.
Yeah, okay. Thank you.
Yes.
So switching gears a minute, back to the data architecture issue. If you have a very, very large, two very, very large tables that don't share a shard key, functionally, I'm sure you can handle that, but practically, is there anything that you offer into that solution?
You can use different, I mean, you can still shard, but they're not going to be part of what we call the same cluster. But again, that's why it's important to know how your queries are working, how each.
So I'm telling you how the part works. There's two very, very large tables, they join, and they don't share a shard key. They don't share a primary key. And it makes no sense to shard on one's foreign key. Is there, I'm not suggesting you can, I'm just asking, is there anything you can do to that solution?
You can shard one, but again, maybe later on, there is, as I said, mentioned before, there is an idea of cascading that we wanted to do, to actually cover cases like that, but it's not implemented yet.
Now, there's a way that people could test their workload against this, right? Isn't there a script that can actually take the queries that you would run, like if you have a query log?
Oh, yes. So this is an analyzer.
Yeah, there's an analyzer that you can use that will tell you how to shard it based on your workload. So that might be a case for that.
But I think with here.
I know what you're saying, and yeah, I can't think of a way to do it either.
I'm just wondering if there's any magic here or not. That's all. This is not,
No magic on this one. I mean, not right now, at least, as I said, there is something that we're planning to do, but it's not implemented yet. And honestly, I don't think we've had the case. I mean, in your case, obviously it is the case, but we didn't have the cases where it was the case. But as Sherry mentioned, this analyzer tool, yeah, exactly, so you can plug your queries and do all the magic. Like it's going to sort of simulate the load that you're having and say, okay, you know, this can work, this cannot work. Okay. Anyone else?
can we compare scale-based to Hadoop? What is the difference? Like, what is the difference between Hadoop and scale-based? Have you ever compared?
No.
No?
And to be honest with you, I'm not that familiar with Hadoop. I haven't worked with it. I just have I cannot compare even. I would have to do the research to tell you. But as far as I know, as far as what I've heard, I don't think you can compare.
Well, there's HBase we do, right? That's the database we do. And that's a non-SQL database.
It's no.
Yeah, it looks really quite different, I think.
Anyone else?
We might let you finish your presentation. Maybe.
I feel I'm being bombarded. Yes.
So, how do you handle, for example, joins? Looks like for writing stuff, it is pretty scalable. Your writes are always going to go somewhere. What about queries? It goes across multiple machines.
We do run them. There is something which is called, and I'm blanking out right now. There is something which is called the bottom line. What we do, we run it on both shards. We do make a decision like that, but we do it in stages. We do aggregate. Okay. But you're right. It depends. Again, it depends, because let's say if the tables that you're joining on a certain shard key, then there's no brainer, right? Because if it's the same shard key, then you all set. If it's, you're right, and there are situations where you have to sort of go here and there, and that we do basically one by one. There's no other way to do it.
Okay, so it's possible that some of those queries could be a bit slow.
Yeah.
That they would have been otherwise.
It can, the same as with the actual database.
Any use cases for this kind of a setup?
What do you mean by use cases?
Use cases meaning in certain cases this solution is good, in certain cases not that much.
Absolutely. Yeah, and that's why we have the analyzer. The analyzer is something, and as I think in the beginning of that, as just basically said, it depends on how your database is set up, how your queries are set up, what are you doing with that. It could happen. There's sharding is not going to help you at all. Just because of your schema, unless you're gonna be willing to change your schema, change your query probably drastically, it's just not scalable that way, and it can happen. And I've seen one situation where it did happen, so it can happen. But it's not the database was not very well designed to begin with. So, but it can happen because of the legacy concern, because of the legacy applications. So yeah.
Is this being used for data warehousing as well, or is it?
It can be used.
Can be.
It can be used.
Because the data warehousing always tends to have a join somewhere.
Yeah, it can be used. I'm waiting.
Go ahead.
Just hurry up and go.
Yeah, why don't we leave the rest of the questions till the end, write them down or something, and then before Victoria can get to us.
Yes, okay, so we covered that pretty much. We moved from that, but I think it's not the topic of discussion. Okay, so again, and I think what I wanted to talk on this slide, basically, we kind of covered, a lot of these questions about the merge, the sort, the aggregation, the joins. So essentially, yeah, we need to make a decision. We're making this decision, and we're, as we're making this decision, we apply one of the certain actions. And as I said before, we do, for the most part, we're trying for the databases to do most of the work as much as we can, as much, maybe modifying some of the queries on the background, and the user doesn't know about this. We're trying to let the database do the work. And some of the challenges, and again, you covered the slides for me, because this is exactly what I wanted to talk about. So, I don't feel like we need to at this point, so unless I'm going to reiterate, grouping, transactions, undistributed tables, foreign keys, deadlock detection. All of these issues that you do need to deal with, unfortunately, some of the things, we can be some of the things are still, minor things, but, we're still in work in progress. Some of the things were already implemented. These main ones that we had to deal with cover, for the most part, the needs. So, and I think I answered most of the questions on this one. Here's a
we're so close, guys. Anyone have any questions left?
Actually, that's last year's question.
Anyone wants to ask more questions?
The answers are optional.
Is it really?
I used to have a frequently asked question page in my personal website, and I didn't put any answers because it wasn't the answer, it was just the questions.
Support guy who used to say, yeah, the questions are cheap, it's the answer.
Yeah.
So like the aggregate for average, the thought that came to mind is you have a very old database and you shard it on like user number, so everyone gets a sequence number. And so many of the older users are on one shard, many of the younger users are on the second shard. You run an average to see what the ages are. Do you get back all the ages for all the records in both shards and then do an average in the scale-based server, or how do you handle things like financial functions and average and things like that?
On that one, yeah.
So
because there's no, otherwise the data is not going to be, your result is not going to.
So there's a handful of fairly mathematical complex functions that you'd have to aggregate only in the scale-based server, and then that scale-based server would get whacked for a while. So how does it decide how much time it's going to spend on something that intense and still continue servicing other queries?
Because we do run in a multi-threaded environment, so it will affect your connection, but it's not necessarily, at least we haven't seen it yet. It doesn't mean it cannot happen, but we haven't seen it yet that it would be that hooked up that it cannot do anything else. It's pretty much normal processing, for the most part. As I said, these are the single cases. There's, yes, of course, the issue on that average, but we haven't seen a drastic issue where you can just see one hand after another, where you will have that problem. But again, it doesn't mean that it cannot happen. If it can happen, there's, on our part, but it's always, I'm not saying that, some of our solutions were not perfect. And, what we do all the time is basically we're asking yourself a question, and either we have a problem or something which comes up in our QA, where we're deciding, okay, we need to improve. There's other ways, there are better ways, there are better mechanisms to do that. Sometimes, the customers, they're saying, you know what, I don't care. Like, I'm going to rewrite. I don't care. Like, I don't want to do anything with, it's always a personal choice. It can be transparent, but sometimes maybe they're saying, well, you know what, I'm just going to write query. I'm really, there's several ways, and I wanted to get rid of this query a long time ago. It just never happened. Okay, so there's, there are choices that you have to make all the time.
Scale-based work with memcached D?
With whom?
Memcached D, a caching layer, if you're caching your results and stuff, is it work interoperate with that?
Well, I'm sure it would, because memcached D is a pass-through, right?
That's true, okay.
So memcached D has no idea that Scalebase is there,
Okay.
but I don't think Scalebase does caching. Memcached D is basically a caching agent that you can put in front of your MySQL servers, and so what you do is, from the application, you query memcached D.
Okay.
Yeah. I just wanted somehow to integrate it into the, yes, of course. You can work, pretty much, again, think about this, if you work with us, you work as with regular database.
Okay.
So as long as you speak MySQL, we speak MySQL protocol. So whatever speaks MySQL protocol, we can support.
In terms of user access, how is user access controlled? You've got these various databases. Is your software control that, or do all the instances control that? And how are they updated?
It's database. User access, we don't control at all, because we don't need to. User is a database user. When you
So you have several copies of that database, so each database has a copy of the users in it. If you have another user, you want to update it somehow.
Yes,
How's that?
and that's what I said, it's partially, it's a part it's a part of, it's a must. You have the same users, yes, absolutely. Access control is on the level of database. We're not going to control it. You're going to give us.
Well, the reason the idea came up, the reason I thought of it was because you don't, the question you had, I don't know what it was, but, you know, I just forgot. But the reason that the access came up is, you don't prioritize queries. Some systems prioritize queries by user. So they know about the user, and they say, well, this user, when he queries, he's more important than the other user in his query.
Two questions. First is, what platforms and architectures do the load balancer and management components run on?
Load balancer Linux.
32?
I mean, of course you want to pick a good machine, but any version of Linux.
32 and 64-bit?
64. We don't, actually we don't run on 32. I mean, we can run on 32, but I've never seen, at least for now, the need for that. We can run, it doesn't matter. But we need a different Java distribution for that. I mean, usually what we do work only with 64.
And is there a separate management component?
The management component, yeah, it's a single, the management component is basically a single entity, not a single entity. It runs under Apache. It's basically provides access to the database, knows everything about the database that you're working with, the shards. It gives you sort of a unified view. Usually it can be run on the same machine where the scale base is running. It can be run, let's say if you have multiple scale bases, it can be run on one. It can be run on a completely, totally different server. It doesn't matter where it's running.
Okay. And second question, pricing. Pricing. How do you guys
Pricing?
price? Yeah.
Talk to the salespeople.
The salesperson is sitting over there. I'm going to put him on the spot.
Yeah, why don't you just come on to this, we can talk after this, okay? Dying for a slice of pizza.
Very good.
All right?
So the answer is the price of a pizza?
Pizza's going for
They
$2
shard the
grand a
pizza.
slice.
Distributed
$2 grand a shard.
$2 grand a shard, yeah.
Exactly. High value.
I feel like I'm dying for a slice of pizza. You guys all ate and then just
Cold.
Take it.
There.
Dig in, we can stop the questions anytime you want.
Yeah.
We'll go all night.
I just want to see how long it's going to continue.
How about you? I don't think we've had a question from
So
you
if you
yet.
need to reshard, is there a cost to, is there a penalty for database or queries, or is there a separate process for resharding?
It's a separate process.
Is it scheduled somehow, or? So is there a scheduler to that or something, so it doesn't?
It can be scheduled, yeah.
Okay.
I mean, it can be usually, I mean, for the most part, I would think that if you want to reshard, you can stop the process. Meaning you can, once we do the resharding, you can kind of stop in the middle. Of course, for us, we can stop in the middle of the process and say, okay, I want to pause it. We're going to get to the stable state where the data, and we will know where each data is. But again, I mean, for the most part, I would think if you want to reshard, it is an additional load on the database, so you would want to do it at night, probably. Like when, or maybe somebody you're running some other activities, maybe where the load on the system is actually lower, because then it's going to execute faster. But yeah, you can pause, you can schedule, you can do whatever you want with that. Yes.
So 2 questions. Back to concurrency, do you have any rules of thumb on, or is it just trial and error as to how many stand up?
Again, can you repeat the question?
Yeah, depending on how many users you have, do you have any rules of thumb as to how many scale-based servers stand up, or is there a heuristic, or?
It depends on how many connections probably you want to, like how many connections you're expecting to have, how many servers. Let's say if you have a bunch of, you have a 20 or 30 or 40 application servers, which each running with 200 to 1,000 connections, right? So you do want to, you know, we do have sort of a matrix as to like how much we would recommend. I mean, I don't have it on me, but we did some benchmark testing with that.
And then the second one is just a curiosity question. Have you had any problems with users killing queries?
No.
Okay.
Why would that be a problem?
Just, I was in a similar space at some point, and it can be a problem.
Okay.
Look at the gentleman behind you nodding his head. He had to do it too.
I mean, I've had problems with users killing queries on regular machines, so I don't know how this would make it better or worse.
Well, you're distributing the kill.
Oh,
And you gotta
yeah.
keep track of your kill. And I didn't want to go down there, but.
Yeah, no,
it's not
I get
true.
it. That was enough.
To face commit problem.
I guess I have a question.
Query.
Does the reshard shard in place, or does it double like the storage requirements temporarily while it reshards? Because I'm assuming if you've got to resplit everything, do you like create separate tables that are resharded on each additional node?
We do it in chunks, so it's
Okay.
not really needed up.
Okay, I was just curious. Okay.
In one of your slides, you mentioned the non-ORM solution. So is there a ORM variant? Does it create
It
any
was
problem?
mostly, I was trying to present, in this slide I was trying to present, if you do, let's say if you want to shard right now, if you want to create your sort of sharded environment, you know, what do you need to do? So these are the things that you as a developer, you need to think about. How do I connect to my database? I mean, for non-ORM solution as a developer, you would probably like provide some sort of layer to access, to actually work with the connections. And for ORM, it's pretty much hidden to you, right? So it's very difficult. I mean, there are ways you can create your own ORM probably somehow. I mean, but it's a lot of work. That's what I was trying to say. I mean, there's no solution in terms of, I'm not saying we provide, meaning you can connect to us, you can use your ORM and provide our scale base. We work with ORM. Okay, so that's what I'm saying. But as I know, there is no solution there in the market. Okay, that's what I'm saying. No more questions, really? Okay, now I can have. Yes.